This is abstract addition and subtraction. Abstract because it replaces numbers that you could actually imagine with variables that represent numbers, but we don't know what those numbers are. So you might think, well, how can we know what those numbers are? There is a way. We won't actually know what the numbers are, but we do have some clues about those numbers. P and Q represent numbers, and they have to follow these rules. In math, they call these conditions, and they're like the rules of a math problem. So these are our two conditions. If we can understand these conditions and then figure out what we're being asked to do and asked to find, then we can solve the problem. So the first step is trying to understand these. So it says, condition 1 is if P and Q are both positive numbers. So what that means is that P and Q have to be, they must be bigger than 0. They have to be positive. That's a rule of the problem. It's one of the things we know about these numbers. We don't know what they are, but we know they're bigger than 0. So next, P is greater than Q. You may have learned this like I did, where the alligator eats the bigger one. P is a bigger number than Q. On a number line, P is more positive. So P is bigger than Q. And I'm writing with the mouse. I know that's terrible, but this is pretty good mouse writing. P is a bigger number than Q. So these are the two things we know about this problem. We don't know what P and Q are, but we know they're both bigger than 0. They're both positive. And we know that P is bigger than Q. So we're being asked, if I took P and I subtracted Q, would my answer be greater than 0? Would it be less than 0, so a negative number? Or would it be equal to 0? So you might be thinking to yourself right now, oh, I get this. If I take a number that's positive and I subtract a smaller number, then I'm going to be above 0. You might be able to figure that out now. You're like, oh, it's greater than. Easy. Or maybe you can't. So here's what you can do. Now that you have the rules, you can replace P and Q with numbers that follow the rules, that follow the conditions. So I'm going to pick a number for P. Let me erase this here. I'm going to pick a number for P, and I'll use 5. I'll just select 5. It's positive, and so far that's following the rule. The second rule for this problem is that P is a larger number than Q. That means Q cannot be 5. It also cannot be 0 because we know Q is bigger than 0. So Q has to be bigger than 0, smaller than 5. So I think I'll just choose 4. What I'm doing is replacing variables, abstract ideas, with concrete numbers, real numbers I can understand. So now, my problem is 5 minus 4. Well, I know that's 1. So in this problem, what I found out is that when I take a number that's greater than 0, subtract a smaller number that's also greater than 0, smaller positive number greater than 0, yep, my answer is going to be greater than 0. Because here I got 1. My answer is going to be greater than 0. So the way I can show this on this vertical number line, up here is positive. All I'm going to do is draw a bar that represents P. There's my number for P. Now we thought of it as 5. So in my head I'm thinking this is 5. What I'm doing is subtracting a smaller number. So from the end, from that distance, this distance is P as a number. I'm taking away Q. I know Q is a smaller number, so that means it is a bar that is not as long as P. It can't be. Otherwise, if it were the same size, if this bar was the same size, P and Q would be equal, but they're not. Q is smaller than P. So what I'm showing here is that if I, on the number line, go from 0 up to P, and then I take away Q, that my answer is above 0. So when you answer these problems, the first thing to do is understand the conditions, and then a little cheat, a little trick, is to replace the variables with real numbers that follow those conditions so you can decide what the answer is.